Okay. Equations. So what we've done so far, we've talked about what the general equations of straight lines are, and well, actually, who can remember? That wasn't what I wanted to know. Who can remember what the two forms of the equation of a straight line are? What's the first one? The what form? General form. So give me an example of an equation in general form.
Y equals m plus
X plus by plus c equals 0.
So that's general form.
Isn't it? It's by, not b again.
Ah, yes, that would be big one, wouldn't it? This is fun. So ax plus by plus c is 0, that's in general form. Now, the disadvantage of putting things in general form is what? You have to work the gradient out, and how do you work the gradient out? Rearrange it.
Sorry, Mr. Gordon, I'm late. I'm talking to Miss Court.
If you are late, you're right. So, a disadvantage, but if you get an answer and it's in general form and you want to leave it in general form, that's fine. What's the other form? Point gradient for gradient intercept form. Y equals mx plus b, where m is the gradient and b is the y-intercept. Okay. So they're the two forms of the equation of a straight line. We then have learnt how to sketch straight lines. And what are the two things you have to always label when you sketch a straight line? Y-intercept and the x-intercept. And the x-intercept is when y is 0, and the y-intercept is when we substitute x equals 0. Or if it's in gradient intercept form, then you can just read it off. And once you've got those 2 points, you can draw your straight line. What's the only time you can't draw a straight line by finding the x and y intercept? When it goes through the origin, in which case what do you do?
In one.
Yeah, find another point. Alright, so equations of perpendicular and parallel lines. What do we know about parallel? So when two lines are parallel,
They'll have the same gradient.
yeah, so when two lines are parallel, you know that m1 equals m2. Yes, bless you, Lucy. So when you see the word parallel, think the gradients are the same. And when we see the word perpendicular, so perpendicular, what does that mean? Yeah, the product of the two gradients, m1 times m2 is negative 1. So what does perpendicular actually mean? It means right angles. So they might just say, if they say show something is perpendicular, you have to show the product of the gradients is negative 1. Or the types of examples we're going to do are where they say, find the equation of the line that is perpendicular to a particular line through a point. Okay, so we're going to do a couple of examples of that. Everyone's seen that before, haven't they?
Yes.
So find the equation of the line passing through some point 2, 1, that is parallel to y equals 3x minus 1. So what information can we get from that?
It's still going to start off as y equals 3x.
Well, yeah, it is. Exactly, it's y.
Because
It's still going to have the same gradient, yeah. So we know the gradient of the line that we want. And what is that gradient? Ooh. That's bad. It's getting confused. Lag, big time, yeah. Maybe it's because I'm recording. Okay, so what do we know? We know that the gradient is 3. Because the gradient of the line y equals 3x minus 1 is 3. We've got a gradient, and then we have a point. The point is 2, 1. So what rule do I use to find the equation of a straight line? Point gradient, which is what? Perfect. And we substitute in our point and our gradient. So therefore, y minus y1, which is 1, equals m, which is 3 outside of x minus 2. Expanding and simplifying, y equals 3x. That would be minus 6 plus 1 is minus 5. And we've found the equation of the straight line that is parallel to y equals 3x minus 1 and passes through the point 2, 1. So the trick with these questions is figuring out what I was asking you, and then it's invariably using the point gradient form. Is that cool? Alright. Find the equation of a line passing through a point 2, negative 3 that is parallel to some line in general form.
Suppose you want to turn around to the other.
Yeah, turn it around to put it into point gradient form. Why? Because we can read the gradient. So, it was your bright idea, Brock, so what do I do?
Subtract 5x.
3y equals 4 minus 5x, yep. So y is minus 5 on 3x plus 4 on 3. Drawing very well, isn't it? It's a 3, by the way.
Maybe you should use.
Maybe I should use a pen. Maybe I use black, see what that works. So we can determine from rearranging the equation in general form that our gradient is negative 5 on 3. And we know the point it has to go through is 2, negative 3. And then it becomes the same as the first question. But I would encourage you that when you're doing these, show what you're doing. Say, I'm rearranging, or demonstrate you're rearranging to put it in point gradient form to find the gradient, and state what the gradient is and what the point is. Because what will happen is occasionally you'll make transcription errors and you won't necessarily copy it down the same way. And if you do that, and it hasn't made it any easier, you will still get full marks. Just because you're an idiot, you wrote it down wrong doesn't mean you lose marks, unless you make it too much easier. So from this we just say y minus y1, which was plus y minus 3, which is y plus 3, equals m, which is minus 5 on 3, outside of x minus 2, which if we expand it in, gives us y equals minus 5, that's a 5 incidentally, minus 5 on 3x and then we'll end up with plus 10 on 3, and I have to take away 9 on 3, which gives us plus 1 on 3. If you're having a bit of trouble with the fractions, that's cool. Just take it in a couple of different steps.
I think you should use the pen, that's probably messy.
Okay, I'll use the pen from now on. But it taps too much. Okay, is everyone clear with that? So rearrange, find the gradient, use the point gradient. Cool. Same sort of thing. Find the equation of a line passing through a particular point. So in this case, 2, negative 3, that's perpendicular to y equals minus 2x plus 5. Yeah. So we know that m1 equals negative 2. So therefore, we know that for lines to be perpendicular, m1 times m2 is going to equal negative 1. Therefore, m2 is negative 1 on m1, or negative 1/2 in this case. All it is it's not negative 1/2, it's positive 1/2. Because that was negative 2, so it's positive 1/2. All it is it's the negative reciprocal of that. Reciprocal meaning you put it over 1, invert it. So now we've got a gradient and a point apply the point gradient formula. Y minus y1, which in this case is 3, equals a half outside of x minus x1, so x minus 2. Y equals a half x. Half times minus 2 is minus 1. Plus 3 is then plus 2. So minus 3 times minus 4. So all the same sort of thing, given a point, given a line, parallel, perpendicular, use the properties of parallel, perpendicular lines. And what's the next obvious example? What will be the next example?
2 points.
No.
Perpendicular lines.
Rearrange and then do it, yes. So perpendicular to 5x minus 2y equals 7, passing through the point at 2, negative 3. I even got lazy, I didn't even change the point. So we need to rearrange this to find the gradient, and we do that by doing rearranging 5x minus 2y. So therefore you get 2y equals 5x minus 7. I did a couple of steps at once there. If you can't follow that, then do it in multiple steps. So y is 5 on 2x minus 7 on 2. So that tells us, in this case, that M1 is 5 on 2, and therefore M2, if they're perpendicular, will be what?
Minus 5 on 2.
No, not minus 5 on 2, but minus...
No, it should be on 1 be minus 5 on 2.
Huh? No.
Oh, because it's supposed to be.
I took that over that side and that over that side.
Okay.
So once you've found the first gradient, then the second gradient of the perpendicular line will be the negative reciprocal. So all I've done is flip that fraction and put a negative sign in front of it. Then straightforward, y plus 3, y minus y1 equals m, which is minus 2 on 5, outside of x minus x1. Which, if we do the fractions again, and unfortunately perpendicular lines invariably end up in fractions. So it's minus 2 on 5x, and I'll end up with plus 4 on 5, and then I'm minusing, I might do this, plus 4 on 5, and then I have to minus 3 on 3, which is 15 on 5. The equation of lines minus 2 on 5 x. Oops. So minus 2 on 5 x plus 4 on 5 minus 15 on 5 is minus. Oh, you're kidding, aren't you? 4 minus 15. What is it? Minus 11. On 5. Okay. Now, when you do these examples from the textbook, they may leave it in general form, and that's fine. I don't care which form it is. Unless it's
In it, sometimes they times it, so it's 5, right?
Yeah.
To do that.
you can. Unless it specifically says put it in point gradient form or in general form, you can put it in general form. Right. Are we happy with that?
Yes.
Does anyone have any questions from the last exercise we did?